There we go. Right, so I'm going to share the screen. There we go. So hopefully everybody can see that from the beginning. Right, so what I was going to share with you first of all, that is at the end of the reception year, these are the expectations that we aim for the children to achieve. This has recently changed with the new framework of their foundation stage. It now is very much, it used to be about knowing numbers 2, 20, addition and subtraction and things like that, but now it's very, very much about the children having a really strong, deep understanding of what 10 is. So being able to count, to recognise the numbers, being able to compare them, being able to break them down into different parts. So knowing all of the number bonds, addition and subtraction facts. So the first one is have a deep understanding of number up to 10, to subitize up to at least 5, which I will explain as we go on what that means. To recall number bonds to 5, so that's knowing about how that number is made, which I've just briefly mentioned. So that 2 and 3 makes 5, 4 and 1 makes 5, and knowing all of those up to 5 and some up to 10, including doubles facts, which are like 4 add 4, 3 add 3, 5 add 5. Then also being able to verbally count beyond 20, comparing quantities up to 10 in lots of different contexts, so not just keeping it to the cubes in the classroom, but into lots of different contexts. And then also being able to explore and represent patterns within numbers up to 10, including odds and evens, doubles facts, and how quantities can be distributed equally. And that part of it is just like your very, very early stages of multiplication and division. Then what that would look like in nursery is this. So what we would like in nursery to be able to do by the end of the year to help them with where we want them to be at the end of reception is to count to 10 and beyond, to count objects and actions up to 10, begin to make comparisons between quantities, so starting to look at the language more, less, or the same. They seem like very simple words, and more, I think, is very much in their vocabulary. Like I would like another biscuit, I want more biscuits, or more sweets, or more ice cream, but less and the same may not be something that's always in their vocabulary, and we can never take for granted that they will know what they mean. Begin to make connections between words, digits, marks, and objects. So it's knowing that numbers are represented in lots of different ways. It's a written word. It can be done as a numeral. It can be represented by 3 lines, 3 squiggles. It also could be 3 cubes, 3 cars. So the numbers all around us are represented in lots of different ways. Then begin to develop an understanding of mathematical vocabulary, more, a lot, the same, and show an interest in number problems. So that would be very much within their play. You know, sort of like when you make a car in the Lego corner, how many wheels are you going to need, and counting them out, or setting up a table when they're working in the role play area and making sure that they've matched the right amount of forks and knives to go with the plates and so forth, which is all things that they need maths for in everyday life. So what I wanted to share with you is a document that I've created for our foundation stage teachers, which is what we call our number sense document. We want the children to have a really, really strong understanding of numbers within 10, and there's lots of elements to that. So the first one being cardinality and counting. Within that, it's just the children really, really understanding, not just counting the numbers, but knowing what each number is worth and having that really deep understanding. So the first one, the very first thing that children need to be able to do is to say numbers in order. And first of all, that would be by rote. So they would just be saying them in order. Chant, it could be chanting. On there, I've put counting rap that we sing in school. It goes, I heard from a little bird, this class is good at maths. And then they say, team, good as gold, let me see your fingers roll. And then they will count 1, 2, 3, 4. And we might have a number track at to help them, so that we're showing the representation of the numeral, but then also we're saying the words, that they're making the connection between the two. We also can do it as in number rhymes. There are lots of different ones, going forwards and backwards. 1, 2, buckle my shoe. 10 in the bed, going backwards. Another one, nice one, counting forwards, is one man went to mow, or one little elephant was playing on a web one day. So all of those sorts of things are ways of just helping them to put numbers in order. And with that as well, it's simple things that you might do in everyday life, like when you're going up the stairs or down the stairs, and counting how many stairs when you go down, counting how long it takes you to go and do something and come back. And when you say go and get your pajamas, see if you can do it by the time I count to 10, and so, or hide and seek. So there's lots of ways of putting that in place. The next one is counting with one-to-one correspondence. I think sometimes people can think that when you're saying numbers in order and by rote, that when a teacher says, or a child's target might be to count reliably 5 objects. And when they count those 5 objects, they've got to be able to touch them and say the number at a time. And so parents will say, well, if they're saying numbers in order, my child could do that to 50. So why have they got a target where they're counting numbers to 5? But the reason for that is because it's a different skill. It's not just reciting numbers in an order like it's learning a rhyme. They've actually got to have a good understanding of counting objects. That I've got some cubes here. So they know that that is 1, and it's 2. So every touch is it got a number name on it. So I've put on here, we use different things in school, like these cubes that I'm showing you now. Numicon pieces, counting dinosaurs. On here you can see that I've got some little buttons on a 5 frame. You can use all sorts of different things. Here from Home Bargains and different places, you can have things like little counting jewels. You can get these in like little glass pebbles that people might have around their candles, or things like that, as little features. And children love them because they're nice and sparkly, so they love to count them. You've also got different things that you might have around when it's different, like seasons. So Mrs. Darby has little pumpkins and things when it was Halloween. Lots of different counting things. It could be bottle tops. I know that Mrs. Darby also uses bottle tops, the tops off the top of the yogurt pouches. We've got little things like little counting ladybirds and bees, and so each time you could be saying to the children, I want you to get me 4 bees, and they've got to count those out and know to stop then at the 4, the number that you need. You can also do that in pictures through the stories that you read, reading a little farm book. How many sheep can you see in the field? How many ducks are in the pond, and things like that. It's all building that experience of that touch counting. And the next one, again, which seems really, really simple, but it really is a teaching point. And I've had children even before, when coming into year 2, that I have to train and teach them this particular counting skill. And it's known that the last number in the count gives the total of the group of objects. And so what I will find that children do is that I've got 4 cubes here. I put them into a tower. So there are my 4 cubes, and you say to the children, well, how many have you got? So they'll do the touch counting and knowing that a number represents each object. So 1, 2, 3, 4. So we've got 4 all together there. So then what we would say to the children, so how many have you got? We've counted 1, 2, 3, 4. So how many have you got? And children, if they haven't quite got this concept, every time that you say, so how many have we got? They'll go 1, 2, 3, 4. And you say, well, so how many have you got? And they'll keep on just counting back to the beginning, rather than knowing that, well, the end count is 4. So I know that I've got 4. I don't need to keep on counting those. And that's a really important concept for them to get hold of, so that they can keep that number in their head later on and be able to count on from it. I've put on here lots of different ways that you can do that. We've got compare bears on there, the little plastic bear, colourful bears. You can encourage children to count them out from a larger group, modelling stopping at the given number. And then you can say, you've asked them to get 5, and you can count over them again and model saying to them, 1, 2, 3, 4, 5. You've got 5 bears, just to model the fact that that last number is the total of the count. So I'll move on to the next one. In fact, actually, I think I'll just stop for a moment and just see if there is anybody that wants to ask any questions. Can you unmute yourselves? If anybody would like to ask anything, then please do. I don't, when the share screen is on, I can't see any of you, and obviously I can't hear anybody. So if there are any questions and things, I just wanted to keep stopping every so often so that you had a chance. So is everyone okay? Should I carry on sharing? Right, let's go back. Pardon? Oh, yes. Yes, or if you want to, if you don't want to say, you could type the question and then I will see that. Right, so go back to sharing my screen. Right, here we go. So on to the next one. Thank you. Right, so I've said to you that one of the skills that children need to have by the end of reception is subitizing. And basically what this means is the children being able to see a quantity in a picture or an array of objects on the table and being able to just know how many there are straight away without counting. And the way in which they do that is by identifying patterns. One of the simplest ways of that is being able to identify those on a dice. All of us, when we're playing a game, we know straight away when we roll the dice that's 5 or 3 or whatever the number is, and that's because we're subitizing. We recognize that pattern. We know that's 6. We know we can see 2 lots of 3. We can see 3 lots of 2, and we just know in our brains we can subitize that that's 6. And that's what we want children to start doing, because when they've got that, that also helps them to start counting on and using mental methods later on. So you can start first of all with just up to 5, like I said, at the end of reception, doing things like this. Dice is a really good way of doing that. Dominoes is a good way of doing that. You can also do things where you've got some objects in your hands and shake them up and then drop them, and then the children have got to work out how many they've got, and you could talk about them, like what patterns can they see within it. For instance, when you look down my middle column on this document, you can see dots spread out in that like 2x3 grid, and there's 4 different ways there where it's showing 4, and we can all subitize and know that that's 4 straight away. And what we need to do with children is then to show them, well, what can you see within that? I can see a line of 3. I can see 1 in the corner, and if I've got 3 and I've got 1, then altogether that is 4. So when they see patterns like that, it's just talking about it, looking at what they can see. On the other side, I can see 2 and I can see another 2. So it's identifying numbers within a larger number so that they can see how many they've got altogether. Another resource that we tend to use a lot in school, and I've got this at home for my children, is what number do I get? Is Numicon, which children may talk about. We use this a lot at school. The more and more familiar they become with these and playing, we squeeze them into Play-Doh. They can fish them out of water, in sand, they can play with them on pegboards, or just have them all fit together in different ways. There's lots of exploring they can do. But with this, they can subitize as well, because they get to know the colours and the shapes of all of the numbers. And obviously with that, you can see that you've got 3 and 2, so they can subitize and know straight away that that's 5. And they could do it that way, and they might see a group of 4 like it is on the dice, and then 1 more. So that's another resource that you could use to subitize. On this side, this is going on to subitizing bigger numbers. So there's a lot more talk. On here, you've got a 10 frame at the top, which is where it's got the red spots and the yellow spots. So you can see that 6 on the 10 frame is spread out in 2 different ways. And so we're trying to encourage the children to see the pattern there. We know that there's 6 straight away because I can see a line of 5 and 1 more. I know that there are 6 yellow ones because I can see a line of 3 and another line of 3, and that makes 6 altogether. When you look at the shells in the picture there, if you put an array of objects down, again, it's just talking to children and seeing what numbers they can identify with inside it. I can see 3 shells at the top, I can see 3 shells at the bottom, I can see 1 shell in the middle. So 3 and 3 is 6 and 1 more is 7. I know that there's 7, and then they'll start to do that quicker in their heads. Another lovely game that you can play is bunny ears, which is a really simple one to play at home, where first of all you might put your fingers up, so you might go like this, and then the children will know that 5 and 5 is 10, or you might hold up 2 and 2, and that's 4, and the children have got to quick fire say what they know and what the smaller parts they can see and how much there is together. And then another way that you can then play it is you shout the number, and your child has to make that number. So you might shout out 5, and then they might do that for their ears because 4 and 1 is 5, or they might do 3 and 2 because that's also 5. And you can see with that that's also starting to look at their number facts, and they're starting to really get an idea of what all these numbers within 10 are made up of. So here's a little one here that is a bit easier to see than on my document. But here we've got 7 represented in 4 different ways, and it's important for them to see these numbers in different patterns. So I don't know how any of you might recognise that the number is 7, but in the first one I would say that there is a line of 3, and I can see that there's a line of 4, so that I know that there's 7. Or you might see it as a 3, and then 1 more. This one you can see a whole line of 7 in a row. I think what helped me was I could see here that there was a slightly wider gap between the 3 spots and the 4 spots, and so that helped me to work out that it was 7 quicker. With this one, I was talking to Miss Haynes about this one earlier, and Miss Haynes saw it as a 4 and then 3, whereas I saw 3 and 3 around the flower, and then the dot in the middle, so 3 and 3, and 1 is 7. And obviously here you've got your 6 and 1 more, or it might be that you can see it in patterns of 2. And then fingers here, 2 different representations for the number 7, which is just like the game of bunny ears that I was telling you about. So here, not only are the children getting the idea of 7 without having to count, because they're using what they know about what's within 7, they're also starting to see the parts of 7, so that, and that's their addition and subtraction facts within numbers up to 10. This part is really important, and the fact that we have understanding the value of each numeral. So it's okay saying, well, this is number 3, this is number 5, this is number 7, but we need the children to really understand the 3-ness of 3, the 5-ness of 5, and really seeing what that's worth. And the way that we would do that is by representing that number in lots of different ways. So you would be able, you could do it by finding different collections of things. You might have a number, and then with that number, they might find a collection. If you're playing in the garden, for instance, they might go and get 5 sticks. They could go and get 5 conkers. They could go and get 5 stones, and then they can see that number represented in lots of different ways with the objects. They also need to see it written as the numeral. They could also see it as jottings, as you can see in my middle column again. They could either see it in patterns that you can see, like somebody's written, like drawn them on with spots onto stones with a Sharpie. You could draw lines. You could make put stickers next to the number, and you could do dashes. So it's really important that they see markings, that they see drawings, that they see an array of different objects, the numeral, hearing the word, that all of those things help them to really get an understanding for the quantity of that number, so that number is not abstract to them. So here is a bigger example of showing that. So here's number 3, and it's represented in 4 different ways. So you've got the word 3, you've got the numeral 3, you've got a drawing of 3 lines, which represents 3, and then you've got 3 cars, which is 3 objects that are representing that number. You've also got the spoken word 3. So it's been by doing that, whenever we introduce a number to the children, that is how we would do it. We would triangulate it with all of those parts to gather that deep understanding of what that number is and what it's worth. Another thing with counting that you wouldn't think that this would throw children, but it can do. If you've got here, I've got little pebbles on here. If you put 6 out into a line and the children count them and there are 6, if you then move those and put them into a different pattern and then say to the children, how many pebbles are there? If the children are not as secure within their number, they will then count them again, and then you'll move the arrangement and then they will count them again. And I think as they start to develop that stronger sense of that 6, and the fact that you've counted them, you've got that final number, and you know that final number is the last one in the count, then it wouldn't throw them that when it doesn't matter how you rearrange it, you are still going to have the same number within that pattern. Oops, sorry everybody. Right, so I'm just going to stop sharing again just to see if anyone's got any questions that they'd like to ask. Is everybody still okay? Because I know I'm flying through you know, a lot of information, so I welcome any questions at all. We all right? I'm relying on you there. Right, so we will go back to sharing the screen then, and I'll carry on. Right, here we go. So then we've talked a lot now about the worth of those numbers, like seeing what 3 actually means, what 5 actually means, how to count, how to touch count. So now what we would also look at, right, just 1 minute, I've got a chat. Someone asked a question. How will the children be assessed on these? The children are assessed as you go along in all the way through foundation stage, but it's always through play and doing activities with the teachers. So it's very much based on what the teacher sees your children doing independently on a regular basis. So it's not you know, a test or anything like that. It is just what they're learning and what the teachers see them doing on a day-to-day basis, and it's all very practical. Does that answer your question, Lauren?
Yeah, that's great. Thank you.
Thank you. I'll just give that a minute. Right, so then with the understanding the concept of more than and less than, like I'd said right at the very beginning, children do you can't take for language granted that they do know the meanings of some of the mathematical language, and some mathematical language as well also doubles up with what we mean in different terms. So for instance, when you have the word leaves, as in a subtraction sentence, you might say you've got 5 sweets and you take away 2, so that leaves you with, but then we also say leaves fall off the trees, and so you have to be really, really careful, making sure we're really, really explicit with this language and that the children understand what they mean. Less being particularly important. I remember my little boy, when he was younger, he always used to say, please can I stay up early? So it just shows they've got it in the right sort of context, but it doesn't always mean that they know exactly what those words mean. So with the concrete apparatus, that we always try to do things with a concrete apparatus, then look at pictures and then go to more mental methods, just to make sure that there is that deep conceptual understanding. So when looking at more or less than and introducing that language, the best thing to do first of all would be to have 2 really obvious groups, one that has got loads of objects in and one that's got very few, so that it's really, really obvious to children which one is more and then which one is less. And then you can mix it up in different ways. What I've also done there is put all the cubes together, all the same colour and all the same size, for them to see. So there's nothing to distract them from what we're trying to achieve. But then you could move on to having piles of objects that are closer in number, and they might have to count them and then see which is less and which is more. You could also then start to change things. So there I've got our counting fruit out. Obviously fruit is all the same kind of thing, but they're all different fruits. So then it's putting slightly more elements into it than what it would be just by having cubes of the same colour and the same size. Then you could also move on to looking at things like compare bears that we have in school, which I know you're not necessarily going to have, but you could use other things. It could be their teddy bears where they have 4 little ones and 2 big ones. And this looks at the misconception of when something's bigger then it's more. Obviously we know that there are 2 bears there, so that is actually less than 4 bears. So it's just helping to overcome the misconceptions that children may have as they go through this concept. You can see there as well, I've put in a picture, and when you're looking at different pictures like that, just through stories and things, it's like how many camels are there at the zoo, how many horses can you see, and which is more? Are there more horses or are there more flamingos? Is there less camels or is there less bears? So you're just using that language. It then also comes to, finally, it would be quite abstract. You just have the numbers, because the children have had all that visual input then from you of all the objects and the pictures. When you then give them a number like 5 or 12, they're starting to get a really good understanding of what those numbers are worth. And so even though that looked really abstract, they've got all those visualizations in their heads to be able to justify which number is more and which one is less. Sorry, it wouldn't go on to the next slide there. So then what you would move on to is, once they've got a good understanding of more and of less, then you would start to look at what the same means. And so it could be that sharing out cookies or sweets or whatever it might be between 2 people, is it fair? Have they got the same, or is it different? Is it if it's not fair, it might be because so and so's got more and someone else has got less. If it is fair, then they're both the same, just so they can see it in a real life context, which I think always provides a better understanding of the language, you know, in the situation that they're familiar with. And the next one, right? So here are just some games that I thought would be a useful thing that you can do at home. Bath time is great for doing maths work. Capacity, you know, when it's full, half full, when things are empty, how much do you think it would take to fill this jug, and all of that sort of thing. But there are also really nice games that you can get. I know my daughter's had one from Boots before, where it's got a lovely little fish in there and some little fish, and you can just scoop them out of the water. So then you could be counting how many you've got. So you've got your counting skills in there. You can then do it as a little competition. They might fish some out, you can fish some out. Who's got more fish, who's got less fish? The person who gets more fish would win the game, and you could keep trying like that, and they get a bit competitive. You could also bring in one more and one less, and talk to the children. So if you've got all these, I've caught 5 fish. Well, if I gave you one more fish, how many fish would you have? If one fish jumped out of the net, you'd have one less. So how many fish would you have now? So there's lots of different variations of that game that would be really, really helpful for children at this age. Number songs are really good for one more and one less. But what I would say with these, that I think makes the understanding a little bit deeper for children and more fun, is that when you're singing 10 in the bed, you could get 10 Barbies, 10 teddy bears or dollies or whatever, and put them in the bed and cover them up. And then you can sing along 10 in the bed, and this one said roll over, so they all rolled over and one fell out, and you can actually role model that one coming out so that they can see that one less means taking one away and counting what's left. The same with 5 little speckled frogs. we've got, I've just seen my devices. Trying to find my, sorry everybody. So I've got a little pot of frogs that I can put onto a log. So hopefully you can all see this, because I can't see what you can see. Oh yeah, at 1 minute, I know how I can get you to see. We'll share. Right, so I'm going to put the frogs onto the log. And you could have like a nice little blue piece of paper there for them to jump into, or you could do this in the bath with something similar. But 5 little speckled frogs sat on the speckle log, eating the most delicious grubs, yum yum. One jumped into the pool where it was nice and cool. Then there were only 4 green speckled frogs. And then you could keep talking through. So we did have 5, but now we've got 1 less, and that only leaves us with 4. So they've got that visualization as well as the rhyme in the numbers. You can also put that along with having a number track. So I've got a number track here with the number blocks on, showing that you did have 5. You see on there, and now sorry, it's back to front on the screen. When you go back one, that it's 4. What's really nice about number tracks like this that you can use is that the children can see how it's getting 1 more each time they go along, because of the visual picture that you can see here. A lot of children will count along the number line, but then don't understand why 7 goes after 8, or why 6 is before 7, and things like that. Whereas on here, you can clearly see with the quantities on there that the numbers are getting bigger by 1 each time. So it's a bit like a staircase. Right, so I'll go back to sharing. On there, right, so we talked about those. Move on to the next one. Thank you. So I've actually got Miss Haynes here as my tech support. So if it goes wrong, some things, but I'm getting a bit stuck, Miss Haynes is helping me out. Right, so we've got things on here like a bingo game. You can have, these are ones that Mrs. Darby has made in the section recently, that they've been doing on a winter theme. So they've been playing it as a bingo game. So you could do as a simple number recognition, like cover the number 2, cover the number 3, or whatever, rolling it on a dice. You could subitize the number on the dice and then cover up the numerals, so you're representing it in different ways as well. But you could also then take it 1 step further and learn about 1 less and 1 more by rolling the dice. Say you've got 4, I want you to cover up 1 more than 4, so then they have to cover up 5 on there. She's also got another one where they can subitize on there, so you can do it the other way around, where you've got a numbered dice, and then they roll the dice, so they've got number 2, then they have to subitize and see where they can find a 2 without even having to count. And then you can move on to as well, where they roll the number on the dice, they've got number 2, and then they've got to subitize the number that is 1 more than 2. So lots of variations to deepen their understanding. You can also play a game of show me. So you can use the number track like we had, so they could have all the numbers out like this, and then you might say to them, show me number 5, show me number 6, show me number 4, and quick fire like that. They find that really good fun. And then once they've got familiar with that, you can say, well, now find me the number that is 1 more than 5. Right, that's 6. Find me the number that is 1 less than 5. That's 4. So there's lots of different ways of using the number line as well. Then we come on to the calculation side of things for reception and nursery, where it's looking at what numbers are made up of. So knowing that all the different ways of making 3, for instance, knowing that 1 and 2 makes 3, 3 and 0 makes 3, 1, 1 and 1 makes 3. And you can explore those sorts of things through lots of different resources. So one of the ones being using cubes. So I'll get my cubes again. This is quite nice to say. I've got 5 here. So if I make a tower with my 5 cubes on there, so they've got their 5 cubes. You've already done a lot of work on subitizing where they will be starting to see this. But they can break these towers up, and then they can see that that 5 they had, they've broken it into 2 parts. They've now got a 3-part and a 2-part, but that made the whole number 5 altogether. Or it might be they break it off again, and then they've got a 4-part and they've got a 1-part, but altogether that makes the 5 that they started with. Another really nice game that I know I've done with my children before is if you had a tray or a baking tin, if you put a piece of paper inside it and draw a line, as you can see on my drawing, it's got like a blue piece of paper with some pebbles on. Well, you could use beans, you can use little glass pebbles, you can use stones, whatever you want to use. But say you had 5, or in this case there's 9, you'd put them all into the middle of the baking tray and you'd shake them. And then when you stop, wherever those objects have landed, you've made a way of making that number. So for instance here, those pebbles, when they've stopped shaking the tray, you've got 4 on one side and 5 on another side. So they know that 9 is the whole number that's inside the baking tray, but they've got 4 in one part and they've got 5 in another part. And those 2 parts make the whole number, which is 9. We also use Numicon a lot for this. The children have in reception, I haven't got one with me today, but they've got these pegboards where they can actually fit on like a jigsaw. So for instance on here, they can fill those holes onto the pegboard, and then you can join up other ones with it. So that way is 10. Then I can also make, sorry, I'll just stop sharing so you can see this better. I keep forgetting that I'm a bit small. There we go. Right, so that's one way of making 10. But then I've also got 10 and 0, and that fits right on the top of it like that. So I know already 10 and 0 is 10, and a 3 and a 7 makes 10. Then I could also put on top of it, I've got an 8-part and a 2-part, and that sits on the top as well. So they can see that all of them are exactly the same worth. That it's that 10 is made up of lots of different parts, and there are lots of different ways that you can do it. I'll go back again. So I know I'm chopping and changing. It's just because the screen's quite small, so I don't think you can see when I'm trying to demonstrate things. Right, so I'll go back onto here. There's also little jottings on there. You can use dominoes to do this as well, where you could find all of the dominoes where it makes 7 and look at the different parts of the dominoes. You can make your own dominoes like I've done on here. So they've got to make dominoes with 6. So how many spots do you put on this side? How many spots do you put on that side? You've got 6 altogether. We also use part whole models, which look like this. So the bigger one here is the whole, and then you're splitting that number into 2 parts. So if I had my 9 pebbles that are on that blue sheet, I'd have 9 up here, but then I'd split them into those 2 parts, but I know that 9 was the whole. And the reason why that's really important is because then once they see that that whole number is made up of 2 parts, it's going to help with subtraction of those facts later on. Which I'll see if I'm going to show you now. Sometimes it works and sometimes it doesn't move. Right, there we go. Right, so with this one, so we've got, I showed you on here that we had 7 and 3. So I'll take this off again now because the picture I'd put on for you is not there anyway. Right, so I've got 10 here, and we talked about the fact that 7 and 3 makes the whole number, which is 10. So those 2 parts that made the 10 were the 7 and the 3, and that's 10 altogether. So if they know that you've got a 7-part and a 3-part that makes 10, they know that if you've got 10, you take away the 3-part, it's going to leave you with the 7-part. If you've got 7 and you add the 3, it's going to give you the whole number, which is 10 altogether. If you've got the 10 and you take away the 7 part, it's going to leave you with the 3. And what can be really effective with this is just dripping it in all of the time, like as a little quick fire thing, putting it behind your back. So you can say, right, so 10, take away 7 at 3 is, because it's backwards on the screen, is 7. 7, add 3 is, and then they can shout out 10. 10, take away 7 is 3. And you can keep doing that with all sorts of different numbers. You could do it with having a 3 and a 1 and knowing that ways of making 4, because it's really important the children don't just know the ways of making 5 and they don't just know the ways of making up 10. They should know all of the ways of making all of the numbers that within 10. So you've got 4 there, and then they can see that that's a 3 part and a 1 part. So if they know that 3 and 1 is 4, then they need to know that 4 take away the 1 is going to leave you with the 3 part. 3, add the 1's going to give you 4 back again. 4, take away the 3 parts, going to leave you with the 1 part. So we call that inverse. So knowing that it's the subtraction is the opposite of addition. So I'll go back to my slides. Thank you. Right, so on here, when we looked at the expectations for the end of the year, it did say on there to explore odd and evens and double facts and sharing. And I'd also explained how that is the first sort of stage of early multiplication and division. So when exploring odd and evens, one of the first things we would do is when the children are looking at numbers, so say you give them the number 5, they would make the number 5, and then they can explore whether it's odd or even by grouping them into 2s. So if you had number 4, you'd group it into 2s, and then it's got none left over. So we talk about the fact that each one has got a partner and there's no odd one out, they're all together. Whereas if you had 5, you'd have your 2 and your 2 and say, oh, I've got 1 left over, there's 1 odd one out, so that they know that 5 is an odd number. It's also starting to help them with their 2 times table and the count of 2. You can also explore that with Numicon. You can see in the picture that I've given where they've been sorted into odd and even, because here I've got 10. From the shape of the numbers, it's so obvious which ones are odd and even, because you can see that this has got partners, 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 partners. So every single part of the 10 has got a partner. So we know that this number is even. There's no one left out. Whereas if you hold up the number 7, it's really, really clear that it is an odd number, because you've got your partners, your partners, your partners. Oh dear, we've got 1 odd one out. So they can start to see it. So talking about the different shapes of the Numicon, grouping things into 2s, that will really help them to see what odd and even means. Double facts. I'll move on to the next slide. So we've got on here, it's really nice to explore that through dominoes again, because you can find all the dominoes that have got doubles on them. So 2 and 2, 3 and 3, 6 and 6, 5 and 5. And then they can count how many all together to work out what the answer is. They could also generate their own from playing with dice. So roll 2 dice, is it a double? Are they both the same? You're also reinforcing your subitizing skills there by not having to count how many, because they've subitized exactly how many spots they've got on each dice. Is it a double? No, it's not. Right, let's do another one, see how many doubles they can find. And you could write those as little number sentences. So obviously the dice that we've got on here, it's 6 and 6. And you can see on one on the other picture that somebody's written that down as a calculation. With sharing, the best way of helping the children to understand this type of calculation is by putting it into real life. I think one of the things that we always say to children of that age is you've got to learn to share. You must share your sweets, you must share your toys. So I think by doing it in this way, it's a concept that they will be able to grasp. It's in a context that they'll understand. So when they're playing with their toys or in role play or whatever, you can give little scenarios like if you've got 10 cars, if you share them between you and me, how many cars are we going to have each? You could also reinforce that with what we talked about with more or less or the same and fair and unfair. Is it equal? Is it the same? Have we shared them out equally? I have 6 sweets, share them with your friend. How many do you have each? You could make a tea party in the role play area with the toy kitchen. We've got 9 cakes. If we share those equally, so that each bear has the same, then how many cakes are we going to have each? So lots of simple things like that, just so they can really see it in context. It's not that they have to look at the division sign or anything like that. It's just getting a really practical early sense of what it's about. Now, how the foundation stage profile has changed now within the assessment is that we don't necessarily assess children anymore on shape and pattern. It's all very heavily based on the deep understanding of 10. But obviously it's still in the curriculum and it is still taught, and we still want the children to be able to do these things by the end of the year, because obviously that sets them up nicely for when they move into the next year group. So by the end of the year in reception, we want the children to be able to use the language of size, weight, capacity, position, distance, time, and money. So use it as knowing big, small, tall, short, heavy, light, full, half full, behind, on top. Vocabulary is such a key thing across the whole of the curriculum now. That it's something that we really explicitly do at school, and we display the words and encourage the children to use them all the time. Recognise and create and describe patterns. Explore characteristics of everyday objects and shapes and use mathematical language to describe them. How that might look in nursery, for any nursery parents that we have on the group, is that they start to show an interest in shape by playing with them, building or making arrangements and patterns and pictures. Begin to categorise objects by shape or size, so they're noticing things that are the same about them. So it might be all these shapes have got points, not necessarily using mathematical language to do with that, but these are all pointy, or all these types of ones can roll. These have got straight parts and things like that. So they're starting to use everyday language like round, tall, and as I said, pointy and things like that. Begin to use vocabulary related to time and position, and then beginning to name some of the common shapes like a square, a triangle, a circle. So there's lots of different things that you can do for shape that are really good fun. So looking for shapes and patterns in the environment, because they're everywhere. Obviously, we know that every object is some kind of shape. So you can see them everywhere on road signs, drains, bus stops. You know, they're everywhere. And so it's quite nice to go and you can take photos of the different things that you can find, how many triangles can you find, how many cylinders, and that type of thing. You can encourage children to use construction kits like Lego, building blocks, all of those different types of things. And you can talk to them about, you know, what shape have you used, or it can even be like drawing around them as well to make pictures, because then you can say, why have you drawn around that triangle to make the roof for your house? And they might say, because I know that roofs are pointy. So they're starting to look at the properties of those different shapes. Why have you used the cylinder? Why have you used that shape for the wheel of the car when they've used the Lego? Or because I know that can roll and the wheels on the car need to turn around. And then you can model, you know, that language to them. Yes, you're right. You know, the wheels on the car, that cylinder is round. You can do junk modelling together, so using like old kitchen rolls and cardboard boxes. My children love making a mess with all their boxes and things in my kitchen. And you can talk about, you know, the different shapes that they've used. You know, what shape is the toilet roll? What shape is that cereal box? Looking at pictures together and discussing the patterns that you can see. Is it a repeating pattern? Is it just a random like dotty pattern? Is it symmetrical where it's the same on both sides? It's also quite nice to do things like, getting out in the garden, and when you're around and about, doing rubbings on sort of like might be drain coverings, or on some grounds or tiles and things like that, and it creates lots of different patterns for them to explore. Shape snap, so you could have, just in the way that we use snap, you could have ones, I think you can get them like from the early learning centre and places, where it just has the shape on the card, and then you do it in the same way. If you put down a triangle and somebody else does it, it's the first to shout snap. Kim's game is a really good one. That is also a really good game for developing their short-term memory. So if you put down, if you've been teaching some shapes, so say you've got a circle, a triangle, a rectangle and a square, and you can lay them all down onto the table and then cover them with a tea towel or a cloth of some sort, and you talk through everything that you've got there. Once you put the cloth over, you can take one away, and then the children have got to try and guess which one is missing, and you remove the cloth. So at the same time, you can reinforce the names of those, but it's not the circle because the circle's there. It's not the triangle because I can see that. It's not the square. So the shape that's missing is the rectangle. So with that, you're reinforcing the names of those shapes and what they look like, but then you're also developing their memory skills as well, which is good for their learning across the curriculum. Guess my shape. I have got a feeling bag here. But I've got, so if I've got this 3D shape, I've got a cone, you can wrap it around in a cloth or put it into a bag where they can't see it. They can just dip their hand in and feel around the shape. Oh, I can feel a circle. I can feel around a line around the edge. I can feel that it's got a point on the shape. And then they can have a go at guessing what they think that shape might be. You can spend time collecting shapes and objects around school, putting them together and making different buildings. I've done this in reception quite a few years back now, but the children went around and collected lots and lots of things. So they had cones and planks and building blocks and party hats, anything that they could get hold of, and then they used all of those everyday objects to make a giant model, and they absolutely loved it. But then they were talking about shape constantly. You can then talk about those shapes, what's the same about them, what's different about them, and start putting them into groups. They might put all the ones that have got points together, they might put all the ones that have got sides together. I might put ones that are flat together and ones that are solid in another pile. But you can encourage them to just go, why have you put all those together? And how are those different? Asking the children what's the same and what's different really helps them to start noticing patterns and similarities, not just in shape, but in numbers and everything across the maths curriculum. Coming towards the end of the presentation, one thing that I'd really like to stress to everybody is it's really important that children are really secure in working with numbers to 10. I hope that through the things that I've shown you, there's a lot more to 10 than just counting to 10 or counting objects. There's a lot that children need to be able to understand within 10. And even if they spend the whole of that reception year looking at numbers within 10, it is so important, because that's the start of the pattern of our number system. And whatever they know about 10 will help them with lots of bigger numbers. So for instance, when they come into year 2, when they are starting, they know really fluently the different ways of making 5, like 3 and 2 is 5, then they will start to know things like 20 and 30 is 50, because of the patterns that are within the number system. They may also have things like, if you've got 2 and you have 3 more and it's 5, then they'll also know that 22 add 3 more is going to be 25, because that's the way the pattern works. And it's not until they're really solid with that we would want to move them on to 20, because extending children in maths isn't about just using all the bigger numbers. It's about them really being able to use and apply and know those numbers inside out. So then on here, I've just put some useful websites that you could use. The bottom one on CBeebies, number blocks. Some of you may be aware of it if your children watch CBeebies at home. I know it's a popular channel. They use that with the number blocks programs a lot in reception and in year 1, and we've even used them sometimes as well for things in year 2. I couldn't recommend them enough. And the national maths, I don't know how to say that, the NCETM anyway, and their website, they really recommend that, and they've put together lots of materials as well to help the children to learn from even more from each episode. I think that it really just helps the children to really visualize, with these little blocks. It helps them to visualize the concept of what they're trying to get across. And there's ones that introduce each number. So there's rhymes and pictures and stories and things that go with 1, 2, 3, all the numbers, even up to the teen numbers. It's also got one on doubles. It's got one on difference. It's got one on the number facts I've talked about. You can buy things to do with number blocks. My little girl's got a set of number blocks where she can actually make them and have the pictures. I'll show you. If I click on it, it'll come off. Sorry. What have I done? Share. Sorry, everybody. Just want to get to the bottom so that I can show you that. So if I just go from there and I press it again, hopefully it'll work this time. Just so that if there's anyone that doesn't know what I mean, these are the number blocks. So for each number, there is an arrangement of blocks, and they're all like their own little character. And there's a story to go for each one as we introduce them. But they also look at lots of other concepts. And I think when we've talked about the fact that you've got the numeral 3, and then you've got these different representations, it really helps the children to see that 3ness of 3 and the 4ness of 4. So for instance, when you introduce the number 3 number block, it won't just count out 3, it will also show 3, but it'll also show that 3 is 1 more than 2. It will show that 1 and 2 makes 3, 2 and 1 makes 3, 3 and 0 is 3, and so it does that composition of all of those numbers. Hopefully you found that useful. I'm going to put the document I shared with you, I'm going to put onto the school website so that you can go to that and refer to it whenever you need. And also I'll put the links onto the dojo as well, so that even when this has gone away, you can still access those 5 things that I've put on there. I'm just going to stop share. Is there any questions or anything that anybody wants to ask me about what I've been sharing today? If you don't want to say anything, you can write it down, or if you want to talk, you can just mute yourselves. No, that's all right then. Well, hopefully then I've given you lots of information, and that, oh look, I told you my cat was going to appear, didn't I? So hopefully that's helped you to support your children at home. If you ever do need any support on this, obviously go to your class teachers, dojo them, but then I'm also here. You can dojo me as well if I can do anything to help and give you lots of ideas. I'm sure the websites that I've given will also give you lots more things. And as I say, number blocks are fantastic. So thank you very much for your support, everybody. Thank you for coming along. And I hope to see you all again soon. All right, bye-bye.